Hi again and welcome back. In the 12th session of our RouterOS and online MTCNA tutorials, we're going to take a look at another network troubleshooting utility. This tool is called Traceroute, and in this video, we'll be covering four main topics. First, a brief overview of Traceroute and how it works. Then, an introduction to hops and network segments. And finally, the Traceroute interface and its features on MikroTik's RouterOS. So, what is Traceroute? Traceroute is a network diagnostic tool that shows you the possible routes and transit delays of trace packets across an IP network. This tool records the history of the trace based on the round-trip times of packets received from each successive host on the route, and provides you with the sum of mean times in each hop as a measure of the total time used to establish the connection. By default, Traceroute continues sending trace packets towards the destination host unless all packets, which are usually 3, are lost more than twice. If that happens, the connection will be lost. The difference between Traceroute and ping is that unlike Traceroute, ping only measures the final round-trip times from the destination host. Most implementations of Traceroute on different operating systems allow users to determine the number of queries to send for each hop, the timeout limit for each response, the number of hops, and the port used for the trace. Now, before we go any further, let's talk about the notion of hop. In computer networking, a hop happens when a packet passes from one network segment to another. Hop count refers to the number of devices through which a packet passes until it reaches the destination host. Based on the protocol being used, the hop count may or may not include the source or the destination. For instance, in the picture given, we have 3 network segments, and for a packet to move from the source computer to the destination host, it has to make 2 hops. Similarly, as for the local network of our MTCNA home lab, we also have 3 available network segments as shown here. For more information on Traceroute in MikroTik's RouterOS, you can refer to the Troubleshooting Tools webpage on MikroTik's wiki. Traceroute, as you can see, also displays the list of routers that a packet travels through on a given route. On Unix-like operating systems, it goes by the names of Traceroute or TracePath, and on Windows, you can find it under the title TraceRT. In Winbox, Traceroute is located under the Tools menu. This is the Traceroute window, and it consists of 3 main sections, namely Basic, Advanced, and the Results table at the bottom. In the Basic section, you first have the Traceroute to field, in which you enter the intended destination address. You also have the option of determining the size and timeout limit of your trace packets. Moreover, you can also opt to choose between the 2 network protocols of ICMP and UDP. For now, however, we will stick with the default protocol of ICMP and leave UDP for future tutorials. As an example of using Traceroute in its basic form, we will try tracing the IP address 8888 from the class access point. By clicking on Start, the trace begins, and since we have not set any packet count or hop limitations, it will continue by default until we hit Stop. As you can see, trace packets from the class AP have to make 15 hops in order to reach the address 8888. You can also see the list of all host IP addresses on this route, as well as the number of sent packets to each host and their loss percentage. Moreover, you are provided with some statistics concerning the quality of your trace, the ongoing real-time history of the trace packets, as well as the status of the packets or the host destinations in case anything specific needs to be reported back. In the Advanced section, you first have the 2 fields of Count and Max hops, which allow you to determine a limit for the number of outgoing trace packets to each destination and the maximum number of hops for the trace. For example, if we set the max hops value to 5 and trace the address 8888, you can see that our packets do not go any further than 5 hops, and we only get the result of 5 hops in the results table. Moving on, you also have the option of determining the source address that will generate the trace packets, as well as the out interface that transmits the packets from your device toward the intended destination address. The field titled DSCP, that stands for Differentiated Services Code Point, is used to determine the priority of packets, which we'll discuss in later tutorials. And the field titled Routing Table allows you to choose your routing table of choice based on which the Traceroute tool will operate. In MikroTik routers, based on static or dynamic routing protocols, we can have more than one routing database that can be used for routing related activities on the network. As for our class AP, we only have one routing table, that is the default or the main routing table. In case more routing tables were available, they could be accessed from the drop-down menu here, but for now, we only have the main routing table, and that is why we only have the main routing table option in that last field. If you wish to know more about routing and routing protocols, we cover them in detail in our MTCRE course, where we go over the 4 modules of static routing, point-to-point addressing, VPN, and OSPF. Feel free to post your questions in the comments section and stick around for the next video, as we're going to use Traceroute in practice and show you how we can use this tool to troubleshoot our MTCNA home lab network.